Okay, so this first question is is essentially two questions on the practical, so practical skills. So it outlines a method to create zinc iodide. So first they weigh out the iodine, dissolve the iodine in ethanol, add an excess of zinc. So an excess means that after the reaction there'll be some zinc left over because there was more zinc than was needed to react. Then they stir the mixture until there was no further change, filter off the excess zinc and evaporate off the ethanol. So the first thing is that they state the ethanol is flammable, so how could the scientists carry out that last step safely, because it evaporates off the ethanol? So you can't use a naked flame, you can't use a Bunsen burner. So instead, what you'd use here is either a water bath, so you'd heat with water bath, or you could heat with an electric heater. Or you could say here for that 1 mark, allow it to evaporate at room temperature. The ethanol probably would evaporate off at room temperature if you left it for long enough. And then the next question says, explain why the scientists add excess zinc rather than excess iodine. So you've got to think about how you'd get rid of the excess substance. And if you added excess iodine, then because iodine would be in solution, it would be quite difficult to remove if there was some of that left. So your first point here, this is 2 marks, the first point is to make sure that all the iodine reacts. So that's why you add excess of anything, to make sure all of the other thing reacts. Now the reason why that's important is because if you did have excess iodine, then that would remain in solution, it wouldn't be a solid. So the second mark is for saying excess iodine would stay in solution, and then say why that's a problem. So the iodine couldn't be filtered off, whereas the zinc can, because it's a solid. Now this next question is a calculation question. So it says calculate the minimum mass of zinc that needs to be added to 0.5 grams of iodine so the iodine fully reacts. So here it is. And what I like you to use when you're answering these questions is a process that I call Mr. T. And Mr. T stands for moles, ratio, and then triangle. So if I take you through this process, the first step is to work out a number of moles of the thing you can work out. And here we have a mass of iodine. So I can work out a number of moles of iodine. So the moles of iodine here is going to equal the mass divided by the MR of iodine. Now notice it's I2, and so you're going to have to do 127 times by 2, which equals 254. So we're going to do 0.500 divided by 254 to give me the moles of the iodine. And that would give me 0.00197. Then the next step is to use the ratio from the equation. And we've got to look at what we're trying to work out. So we're trying to work out the minimum mass of zinc that needs to be added. So we're looking at this bit, and actually the ratio of iodine to zinc is just 1 to 1. We're just looking at the big numbers in front of the compounds or elements in the reaction equation. And there's no number in front of them this time, so that means the number is 1, and so this is 1 to 1. So that means that the moles of zinc is going to equal the moles of the iodine, which equals 0.00197. The last step, T stands for triangles. The last step is to use the appropriate triangle to work out what you've got to work out. And you know 2 triangles that relates to moles. You've got mass equals moles times the MR, and you've got moles equals concentration times volume. So which one of these has the thing we want to work out in it? So we're going to try and work out the mass, and the one that has mass in is the top triangle here, mass equals moles times MR. So to work out the mass of the zinc, that's going to equal moles, which is 0.00197, multiplied by the MR, which is 65, which is up here, and that gives you 0.128 grams. The next question says a different scientist makes zinc iodide by the same method. The scientist obtains 12.5 grams of zinc iodide. the percentage yield of the reaction is 90%. What is the maximum theoretical mass of zinc iodide produced in this reaction? So this requires you to use the percentage yield equation. So percentage yield equals the obtained yield, or the actual yield, divided by the predicted yield, or the maximum yield you could get based on the reaction, times by 100. So we've been given the percentage yield, which is 92, and that gives them the actual yield. So it tells you that they obtained 12.5 grams, and that's divided by the predicted yield, which is what we're trying to work out, times by 100. So the first thing to do is divide both sides by 100. So 92 divided by 100 equals 12.5 divided by x, which is 0.92 equals 12.5 divided by x, times both sides by x, so 0.92 equals 0.92x equals 12.5, and then to get x by itself, I divide both sides by 0.92, and that gives me 13.6 grams. So the next question is another practical question. So it's just one reason why the percentage yield of this reaction is not 100%. So the main step where some might be lost here is where you're filtering off the zinc. So the mark scheme here says that some product would be lost on separation, but they would also allow the idea that you might have an incomplete reaction happening. So it might not all react with the zinc and the iodine. And this last question says a scientist makes a solution of zinc iodide with a concentration of 0.1 mol per dm cubed. Calculate the mass of zinc iodide required to make this solution. So the first thing to do here, as with Mr. T, is to work out the number of moles that are involved. So the moles of zinc iodide that's required will equal, I'm going to use this triangle, the moles equals concentration times volume, equals the concentration, which is 0.1, times by 250. Now, because the 250 is in centimetres cubed, and the concentration's in decimeters cubed, I then also have to divide this by 1,000 to ensure that this 250 centimetres cubed is in decimeters cubed instead. And that gives me 0.025. Now, in terms of the ratio, in this case, it's not really relevant, but basically I need to make sure that there's that 0.025 moles of zinc iodine. It asks you to work out the mass. So the next step here, triangle, is to use the appropriate triangle, and the mass triangle is mass equals moles times mR. So the moles here, so the mass of zinc iodide would equal the moles, which is 0.025, times by the mR of zinc iodide, which you need to work out. So the mR of zinc iodide equals 65 for the zinc plus 2 times 127 for the iodine, which equals 319. So I'm going to multiply that by 319, and that gives me 7.98 grams.